Comparing rational numbers, part 1. Let's take a look at these two rational numbers. We have 9.02 and 9.2%. To be able to compare rational numbers fairly, they need to be in the same form. There's a lot of ways to do this, but for me, the easiest way to compare rational numbers is to put them in decimal form. Decimal is the middle ground. It usually takes one step to get a fraction to a decimal and one step to get a percent to a decimal. That's why I like to turn everything into decimals. So I'm going to turn this percent into a decimal. I already have a decimal here. And don't be fooled. This is a decimal, but it's also a percent. So if there is a percent sign on the decimal, it still needs to be converted into a true decimal before you can compare it to another true decimal. To turn 9.2% into a decimal, you divide it by 100 and you end up with 0.092. Before comparing decimals, to make sure you have a fair comparison, I like to make sure all my place values are set. In this number, I have 3 digits after the decimal. In this number, I only have 2. I'm going to add a 0 here to make sure that everything is fair. The first thing I want to do is take a look at my whole numbers. That's the number in front of the decimal point, so the numbers to the left of the decimal point. If they are the same, you cannot use them for comparison. However, if they are different, you can use them to compare. So if you look at the numbers that I've underlined, the 9 and the 0, they are different. I can use these numbers to compare my decimals. 9 and 0 can be compared. When I compare numbers, I like to look for the larger number. So between 9 and 0, 9 is my larger number. So that means 9.02 is greater than 9.2%. So I need to use the greater than symbol. I like to think of it as Pac-Man. So Pac-Man is going to eat the larger number. So the large mouth needs to be facing the bigger number. Here's our next example. We have 2 fractions. I'm going to turn them both into decimals. Here, I have turned them both into decimals. To turn a fraction into a decimal, you divide the numerator by the denominator or divide the top by the bottom. So before I start comparing, I want to make sure I have a fair chance. So I have 2 digits after the decimal place here. I want to make sure I have 2 digits after the decimal in my first number, so I put a 0. Now, make sure when you're adding zeros after a number, you can only do that after a decimal point. So make sure if you start adding zeros after a number, you're doing that after a decimal point. So now I need to start comparing. If I look at the number in front of my decimal point, my whole number, the number to the left, both numbers have a 0 in the ones place or the whole number spot. So I cannot use those to compare. So I'm going to cross those out and I'm going to move on to the tenths place, the first digit after my decimal point. Well, if you look, both of those are 6s. Again, I cannot use those to compare. So I have to use the hundredths place. Well, again, I like to look for larger numbers. So 5 is my larger digit, my larger number. However, these numbers are negative, so we need to be careful. Even though 5 is our larger number, the bigger the negative, the smaller the number. Because negatives are opposite of positives, the opposite is true on the negative side. So if 5 is bigger on the positive side, That means on the negative side, this is really my small number, which makes this my big number because they're negative. The bigger the negative, the smaller it is. So be very careful when you are dealing with negatives. So I need my greater than symbol for this comparison. Negative 3/5 is greater than negative 13/20 because they are negative. The bigger the negative, the smaller it is. This fraction is actually closer to 0. Negative 3/5 is closer to 0, which makes it a larger number. So Pac-Man needs to eat that fraction. The alligator, Pac-Man, whatever you call it, you need your greater than symbol. In our last example for this part, we have decimals, but we do not have a fair chance to compare because we have an unfair advantage because this has more digits. So I need to make sure this has the correct amount of digits after the decimal point. I can add a 0 after the decimal point so that I can have 3 digits for this number as well. Well, now if you look, they are exactly the same, which means that these two numbers are equal.